the number of adults who are functionally innumerate, 20%. The number of kids who are dyscalculic, 5-6%. It's never going to be precise because the definition is not something you can measure like the length of a piece of string. So I'm a teacher. I've been a teacher for a long time. I moved from mainstream education, where I taught physics, chemistry, maths, to work or to be head of a new secondary school for dyslexics. That was in 1981. And because I was a science type person, they said, teach them maths. And I discovered it was just a little bit more complicated than that. And back then, there was nowhere to go to get help. No one knew much about maths. So my early experience was maths and dyslexia, not dyscalculia, because we didn't have that word in common usage back then. The school had a twin school in America, and I ended up being visiting head of that school. It had some admin troubles. And I studied in America and studied with the two guys who ran the school who were brilliant. And we started to really look into maths and dyslexia. Did a lot of work on cognitive style. But to do that, I had to give up my job. My boss wouldn't give me leave of absence. So I came back to England and set up my own school in 1986. And that was for very dyslexic boys. There's still, in those days, there were very few girls who were diagnosed with dyslexia. And I built that up to have 80 boys in it, which was big enough. We played rugby with 80 boys, beating a lot of the local comprehensive schools, because they're pretty fierce when they got warmed up. And we won awards, and they got good GCSEs, and they went on. And on a good day, they write to me, but they are very dyslexic, so it has to be a good day. And that school I sold to the Priory Group in 2005. During all those years, I studied with some people in Ireland and Holland, and kept contact with America, did a lot of research, a lot of writing. And so now I know quite a bit about dyscalculia. But after all those years, I ought to really. And I still lecture. I've trained teachers in 30 countries around the world. And I've written a number of books. Got a new one coming out in 2 weeks' time, which is called How to Teach Maths, which sounds arrogant, but then the next bit is Understanding Learners' Needs. So it's based on the idea that, turn that light off, it's ruining my skin tone. It's based on the idea that mainstream teaching could learn from looking at the outliers. And then the outliers is a term that gets used a bit in America. And that's where I picked it up, from a pioneering computer group in Boston. So I think, and with years of mainstream behind me as well, that if I'd known back then what I know after working with dyslexics and dyscalculics, I'd have been even better. Well, I'd have been better. So, and I still do webinars. We do some training courses with Judy Hornigold, and I've produced some training some teaching videos prior to lockdown even. So Maths Explained is out there to help parents, and looking at the technology, even though I don't understand how it works. But it's wonderful for teaching, So,
that's amazing. So it's quite a journey. Do you still do rugby?
Me, I was a little tiny, skinny kid with terribly poor eyesight. I couldn't see a rugby ball if it was 10 feet away. And then I was
so watch on the sidelines.
I was the only player that could hide behind the rugby post, and that's before they put the padding on.
Brilliant.
But I played hockey. I liked hockey.
It's fascinating, your journey, and I only wish we had longer to kind of speak. So you touched upon about your latest book about how to teach maths. So let's delve straight into it. So one of the questions I wanted to ask you was, what sort of behaviours does a child who shows good number sense, what sort of behaviours do they display? So a child that has good number sense, what do they display?
That has good number sense.
Has good number sense.
Yeah, I like the positive, coming in on the positive. It's often difficult to answer that question too directly, because so much of maths is taught by rote and by having to remember. So you don't always discover that a kid has got good number sense, because if they remember, that gets a lot of kids by. However, if they haven't got good number sense, they'll probably give up. And asking teachers for years and years and around the world, lots of kids give up on maths at round about 7. And that's when the memory load gets very high. So if they've got good memory sense, they'll link and they'll see patterns. And they can do things like reversing sequences. If you've got a kid who's struggling with maths, ask them to count backwards from 21 in odd numbers. And that's cruelty. That is actually cruel to them. So being able to reverse stuff is part of number sense, part of working memory, because if it's not automatic, you have to hold the forward sequence and then reverse it. And that's called working memory. Well, one example. And lots of kids who struggle with maths have poor working memories. Lots of research on that. Kids with poor number sense often can't estimate. So if you say to them, what's 123 plus 99, they won't add 100 and take off 1. They don't see the 100 as an estimate. And when you walk around shops, you see 99s everywhere, don't you, on prices?
Yes.
It's called psychological pricing, and it works on the principle that people don't think 14.99 is 15 quid. Because my wife, when we were first married, don't ask me about marriages, used to say, she was saying, those shoes, they're only £32. I say, no, they're £32.99, which means they're £33. And this is one way to be told never to shop with me again. I just pass this on to help marriages as well as do maths.
Take away the whole bargain thing. Just when you think you've got a bargain, you remind us that actually not a bargain.
No. So I think number sense is about that comfort with numbers, estimation, sequencing, seeing patterns, and like a slightly more advanced example, kids who are good with number will do 5% as half of 10%. They'll see that, whereas other kids just have to use a formula. They got to do a formula for 10%, a formula for 5%. And that comfort with numbers isn't just about the numbers, it's about the things you do with them, the adds and the subtracts and the multiplies. So there you go. One little thing, and place value, understanding place value, what each digit in a number means. And teen numbers are funny. The first time you meet 2-digit numbers, which is place value, is 11 and 12, which have no language pattern at all. And then you say 13 and you write 1, 3.
Yeah.
And then you say 23 and you write 2, 3, and so on. So the first time kids meet two-digit numbers, they're confusing linguistically.
The language, yeah.
Yeah, and we don't like inconsistency. So that's kind of what kids were good at. Yeah,
So,
they'll be good at those things.
So on the flip side then, you touched upon dyscalculia. Could you, in layman's terms, sort of kind of explain what dyscalculia means? Because I do feel like dyslexia is spoken an awful lot, and perhaps people have a little bit more of an understanding of dyslexia. But I wouldn't be convinced that all teachers are confident in spotting a child that perhaps has dyscalculia, and what does it look like, and what behaviours do they demonstrate?
Yeah, it's dyscalculia.
Dyscalculia. See? Dyscalculia.
Yeah. The BBC rang me up to say, how do you say it? I said, I'm a Midlander, don't ask me. So, dyscalculia, it's hard. I'm not wiggling out of this. It's very hard to define people because they're so heterogeneous, you know? So the first thing to realize is there'll be a spectrum. And there isn't a sudden cutoff where you're dyscalculic. This is almost heresy. And there are a number of things that contribute to being dyscalculic. The signs of dyscalculia, what you'll see physically, are poor ability to remember basic facts, poor ability with sequencing, which I've mentioned before. Some people of late, the British Dyslexia Association, have brought in high anxiety, which is a thing you don't get as much with geography or art, but maths, people write books about maths anxiety. And so it's those very key early building blocks that are the precursors of dyscalculia. Now, to get a little bit technical, Professor Brian Butterworth, who is now emeritus professor, which means he and I are old, he's the pioneer and just a great guy. And he has two little characteristics which in everyday life you don't see as much. But these are specific to his definition or understanding of dyscalculia. So he shows kids or adults, because it doesn't go away, a card or a visual image on the screen with maybe 2, 3, 4 or 5 dots randomly organized or randomly disorganized. And they see it quickly and have to know. So unless they can hold the image and count it, it's meant to be an immediate understanding that 3 is 3. And theoretically, it's up to 5. And that's called subitizing. And that's one of the key characteristics that might distinguish a dyscalculic from a kid who's not good at maths. The other one you might have seen, sometimes in magazines, they write the word of a colour, like yellow, but they write it in red print. And then they write blue in green. And you have to say what you have to read the word and not the colour. And that's, you're getting 2 messages. Well, the mathematical equivalent of that, again, Butterworth does this, is he puts 2 digits on a screen. Sometimes they're the same size, the same font size. Sometimes, say, the 8 is a big font and the 3 is a little font. But sometimes the 4 is a big font and the 9 is a little font.
Okay.
So it's that security between the symbolic nature of the symbol and physical size of it. That confidence of knowing what numbers are about. And those two things, that's called Stroop. And those two things distinguish in Butterworth's model a dyscalculic from a kid who's poor at maths. The number of adults who are functionally innumerate, 20%. The number of kids who are dyscalculic, 5-6%. It's never going to be precise because the definition is not something you can measure like the length of a piece of string. It's trying to measure people, and there are so many things going on. The other thing I would say is it perseveres. It's very hard to address it. And for teachers, because, I was a teacher for God knows how many years, we get a lot of stick, we get the blame for a lot of things. But there's no training. There's no training. Well, no is a strong word for such a short word. But there's very, very little teaching. And even now, dyslexia has been known about for decades. Is there a dyslexia module in initial teacher training? No. So you're not going to see a dyscalculia module in initial teacher training for a long, long time. And yet, with the title of the book I mentioned, you will learn so much about teaching kids who can't learn. If you stand in front of a class and tell them stuff and they all remember it, where's the challenge in that? So,
well, it's fascinating. I love the strategy of having the big 4 and the little 9, and
yeah. Well, you see another thing, because it all links together and it all develops. So later on, times tables, I am furious on a daily basis with the obsession with learning times tables. If you look at Pinterest, there's something like 200 pins that have wonderful ways, wonderful music for learning times tables. And some of them are so bizarre, it's untrue. The one that most kids and adults will know is I ate and ate until I was sick on the floor. There you go, you see.
Wakey, wakey, rise and shine, 7 7s are 49.
Yeah. Now, this is wonderful, but what the heck does that teach you in terms of maths? It's nuts. And that means you have to have a little rhyme. There are only 121 facts, so you've got to have 121 little rhymes. I overstated that case slightly.
Yeah.
So, but I like the things, so to go back to the 99, because everything links together. If you learn that 9 is 1 less than 10, and you use that, it's brilliant. So, for example, if I wanted to know what 8 9s are, 8 10s are 80. Well, that's too much. And I take 8 off. So, and it's this the same. Once you know the rule, 7 8, 7 9s, 7 10s, take 7 off.
It's that whole manipulation, isn't it, of using what you know
to work out what you don't know.
Yeah, I often use that line many times. Use what you know to find out what you don't know. It's just
That was a massive. America does research on a big scale, except for politics, of course. So they spent millions on learning how to teach kids fractions, millions. But they did some very good research across the national research, and they had 3 key findings at the end of it. The second one was effectively saying, use what you know to work out what you don't know. And it's brilliant. So, like I've learned so much of what I've learned from kids. If you listen to kids, you'll pick up stuff all the time. And the great question with kids is, how did you do that? I like that. How did you do that? Never say it's brilliant, because that's up in the ante. I like that. then, they don't have to be brilliant next time then.
It's very hard to be brilliant all the time.
Well, I'm struggling. So, and you learn stuff. So they play with numbers. So I remember one kid, 3 sixes, 18, he said. I said, oh, wow, that was quick. How do you do that? He said, well, I know 6 sixes and then I halve it. No, that's maths. That's using maths to learn maths. So sick on the floor, that's just a horrible image. But you can use maths to learn maths. And you have, what I found with my kids, because with the school, when they came for interview, I'd say, how are you getting on with your times tables? And they'd say, well, I'd say, which ones do you reckon you know? Back would come the answer. I know my 2s, my 5s, so is my 10s. And then the smart kids would say, and my 1s and my 0s, because that's 2 more. So, and I stopped asking. I'm not into 11 and 12, but 11's good. Why we're learning the 12 times table these days, I've no idea. No one's told the government we decimatized in 1972. But then you can use those to work everything out. So if you know 5 sixes, and this is maths, that if you know that 5 sixes make 30, 1 more 6 is 6 sixes, and that makes 36. And that actually is the basis of long multiplication.
Yes.
Because when you multiply by 37, you multiply by 7 and by 30 and put the bits together. So it's looking at how maths develops upwards, but also looking at how it develops backwards as well, to see where it comes from. An intervention should always go back until you're absolutely sure you've hit security and foundations. And then as you progress, as you reach a new topic, you look back at where it's come from. Quick revision, top up the brain. It's brilliant. One last thing on times tables. Research from 1925 and then repeated over the years. I wasn't around to read it originally. When you learn something for the first time, your brain doesn't know whether it's right or wrong. It's the first time it's learned it. And if you're not careful, that gets established in the brain. So then you have to unlearn it. And there's quite a bit, there's some research coming out now about inhibiting stuff that you don't need to get the new stuff in. So on a very facile, my wife's best friend is called Sylvia. Yeah. When I first met her, I thought she was called Sheila. And it was 3 years I called her Sheila, till I managed to inhibit that. And as you see, then I had to think about it. And eventually it was good because she knew it was me speaking to her, because I was the only person that called her Sheila. So it was, but you can't do that with maths. It's not quite the same. Yeah, I just love your answer to 7 8s. I think 73 is a wonderful answer. It's so you.
Yes.
You can't do it.
I love to hear you repeat it over and over again. So, and I know obviously this is a short interview, and there's no way we can cover everything there is in it as a whistle stop. So, if you were to give teachers advice now on how to help and support those children who either have learnt it wrong and need to be inhibited and unlearn it to relearn it again, or children who have dyscalculia.
Yeah. Great pronunciation. Yeah.
Thank you. I learned from the best. And just generally those children who haven't got a good number sense, as you said, the spectrum. what hot tips would you give teachers?
Okay, watch speed. Don't ask them to do maths too quickly. Kids hate that. And these are not always just the kids who struggle. Lots of kids don't like doing it fast. Some do, obviously, but that's one of the big deals. If you find out which of your kids have got poor short-term memories and poor working memories. If they've got poor short-term memories, repeat the question, but do it for other people as well, so it isn't just that. You don't identify them. Or you might say, I'm going to ask you 23 plus 7. I'll be back in a minute. I'm back. What was 23 plus 7 then? And it's given their working memory time to think about it as well.
Okay.
And that gives them success. Never give marks out loud, because that's humiliation for a lot of kids. If you give a time test, a lot of kids will just miss out questions. And if kids don't answer questions, you don't learn anything. Try not to mark questions just as wrong, but say things like, I can see what happened here, ask me. Or get the kid and say, what did you do here? Because normally we just say wrong. We don't say why you're wrong. Some kids can't organise their work on the page. Some mathematical procedures require very good organisational skills. So you might want to think about squared paper. But again, don't necessarily just give the poor kids squared paper, because we don't want to keep highlighting them. What else would I give them? A times table square. You can be prepared to give out lots. My younger daughter had very significant special needs. This was after I moved into this area and went to a special school eventually. I don't ask me about inclusion and things. And the teacher always had a box of pencils on the table. And so the kids were never short of a pencil. But she also was very good at collecting them in at the end, because kids are good at forgetting to bring one, but they're pretty good at remembering to take one. And so the same with the times table squares. You can get a folding times table square, because some kids can't track, it's a square, and they can't track down and across. But the folding times table, you can fold it and find that. That's called flexi table, so that's dead easy to remember.
Flexi table.
Yeah, with an I, of course. So you can find it on Google, as you can most things. Watch how much homework you give them. And if you can, and you've got to think about how you can manage this in a classroom, but it's kind of good if they can do a couple of questions before they go home, because if they get those two wrong, they're going to go home and get 8 more wrong.
Yes.
And that's no help to anybody. So, because they've learned the wrong thing.
And then you therefore learn it.
Yeah. So, and you just keep an eye, because of this withdrawal. This withdrawal is such a big issue for all ages. Kids start, as I say, I asked teachers, what age you notice enough kids giving up for you to notice 7. That's enough kids, that's not every kid. And in the research I've done with older kids on doing regular maths, one of the most common errors is the no attempt. They look at it and they think, I'm going to get this wrong. So they don't try. So look for those. What stopped you doing this question? Conversation with kids is wonderful. And you can bet your sweet life it'll rarely be one kid. I mean, even if the 5% rate is right, that's one or two in every class. But the 20% of functionally enumerate, that's 6, 8 kids in a class. So try and teach for everybody. That's and you'll help everybody. Don't assume. So that's a few things.
Well, you've given so many things there. I think many teachers will certainly give them food for thought and change their perspective on so many things. And I loved what you said there about the speed thing, because there is this, it's almost like a cultural thing where maths has got to be done quickly in order for you to be successful. Oh, wow, you whizzed through that and you did that super quickly, and everything's timed, and I mean, even times tables, and I'm guilty of it myself. Let's put the timer on, see how quickly you can complete the times table chart. And just one other thing I just want to say, just before we end, I did a lot of kind of work on this in terms of changing perspectives of parents. It seemed to be like a cultural acceptance for parents to say, I can't do maths.
Yeah.
And yet they wouldn't necessarily say that about reading or spelling. But it seemed to be culturally acceptable and almost laughable. Oh, I was never good at maths at school, or I can't do maths. And I really do think it's something I feel quite passionate about, that I think we need to change as a society. The language we use around children as adults in terms of our own personal experience of maths in school, be it negative or positive, it's just.
Yeah.
So, thank you, Steve.
You're welcome.
I've thoroughly enjoyed talking to you this evening, and really, I'm going to take lots of nuggets from that, and I'm sure whoever's going to watch this will equally find it useful, and I'm sure help many. And good luck with the release of your new book. So just remind us, it's called...
Okay, two things. The book's called How to Teach Maths, which sounds arrogant till you get a bit by understanding learners, and the video tutorials, which are low-cost Maths Explained.
Brilliant.
Thank you for watching. I hope you found it enjoyable and useful. In the comment box below, please put a question or a comment about the video. To grow our community more and help other teachers out there, please subscribe to the channel and share our posts and videos. Thank you.